calculator is I still have the 49.3987 in there. So what I'm going to do is say that I want 112 divided by the sign, and then I can plug in second answer function. So second answer, close the parentheses, and it's going to plug in my 49.383987, etc., and hit return, and it comes up to 147.51. In other words, we could basically just round that off and call it 148 miles that the two ships are apart after 4 hours at sea. Well, now I would like to give you the opportunity to solve a problem involving bearings on your own. A ship travels 50 kilometers on a bearing of 27 degrees and then travels on a bearing of 117 degrees for 140 kilometers. Find the distance x between the starting point and the ending point. Now, pause the video while you work on this problem, and when you've finished, restart the video to check your solution. All right, let's find out how you did on this problem. I have a book diagram that I want to start off by showing you, and then we'll transfer that to the board. So here we have the ship, which originally starts off on its bearing of 117 degrees. And we have the other bearing of 27 degrees, and we have the two distances of 50 kilometers and 140 kilometers. We're interested again in x, the distance that the ship is actually from the port after dealing with those two bearings and distances. And before I move to the board, what I want to show you is that this angle inside the triangle is in fact a right angle. And the reason we know that is we transfer this bearing of 27 degrees up to here. And what that tells me then is that this angle inside here with the double arc would be 117 degrees minus 27 degrees, which gives me 90 degrees. And of course, if that's 90 degrees here, then this one also has to be 90 degrees. So now what I can do is take that information that I'm dealing with a right triangle again, and then put it onto the green board, and we can continue with that problem. Okay, so my triangle looks like this, where I have a right angle. I know that this is equal to 50, and this is equal to 140. I'm interested in angle x. So once again, if I choose one of these angles to call it theta, then I can use the tangent of theta is equal to the opposite over the adjacent. So tan theta is the opposite over the adjacent, which of course I can reduce to 5/14. Now, on the calculator, we can figure out that theta is going to be the tan inverse of 5/14. So let me do that right now on the calculator, where we will type in second tan, which gives me tan inverse, and then 5 divided by 14, close the parentheses, and hit enter. And what I come up with is 19.6538, etc. degrees. So now I can take that and, for instance, use either the sine or cosine to find the hypotenuse x. So let's set that one up right now. I can take, and this time let me use cosine since last time I used sine. So the cosine of that angle theta, which I'll leave as theta for the moment, is going to be the adjacent side over the hypotenuse. And that means the hypotenuse is equal to 140 over the cosine of theta. But of course, theta we have in our calculator, so let's move over and calculate this. So I want to say that it's 140 divided by the cosine, and I want to take my answer of 19.65, so I do second answer, close the parentheses, hit enter, and that works out to 148.66, etc. Now, again, since the lengths that we're dealing with so far are whole numbers, we will approximate this as the whole number of 149 kilometers. Okay, great work in today's lesson. We've only been able to touch on a few of the application problems presented in this section. To improve your proficiency in solving right triangle problems, be sure to work the exercises that your teacher assigns, and we'll see you next time.